How many of you use Riak or Cassandra? 1, 2, 3, 4. Cassandra or Riak? Cassandra. Okay. How many of you use a database in production? Okay, so we know what we are going to talk about. How many of you are developers? Mostly. How many of you are operators? Okay, good. Riak and Guga. What is? I work for Guga. Guga does games, games for phones, for tablets, for Facebook. We have several teams that does each of the games. Each team is totally independent, meaning that all the backend and all the frontend is going to be built from scratch. This is nice because it allows us, developers, to play with a lot of technologies. You start a new project, this is nice, okay, let's play with this, this works, maybe we use it, maybe we don't. So, I did that on the past, and we start showing some common patterns in different games. Things that are happening again and again and again. Will be nice if we create one backend that can be used by different games. Well, not on all the cases, but still on a few of them, it's profit. So we start saying, okay, let's create something. As long as maybe not all the games go to production, we need to develop fast. We need to ship really, really fast the games. We start with prototypes. A few of them goes to production. Most of the times are going to be canceled. Now, the objective is that you have a hit filter. Now, if it is not going to be profit, we cancel it. So we create this team, and we needed to create some API. So how it's going to be to look the backend? We say, okay, it should have an API. It should be a key value store where you have the score of a player and you save the score of a player. And when your friend asks for the score, you ask for that. And it have to have a few extras like security and authorization. The timing was perfect. We have a target game for test this thing. Was Yearlist Plus. Yearlist Plus is a match 3 game, something that you have to trace lines and get some score. You share that score with your friends, and you have to be better than them. So we start thinking, how we can do that? How many of you know Sinatra? Ruby, good. We choose Sinatra, was easy. Who of you work with Amazon? Yeah, good. Who loves Chef? Okay. For database, we choose Riak. On that moment, we were having several people with previous experience at the company with Riak. Cassandra was kind of maybe too much for our use case. We don't need all the query language. We were kind of really attracted by the idea of, okay, you throw more nodes to the cluster, you are getting out of capacity, you throw one node and all the things start balancing and working. Good, perfect. That sounds really good. So the final structure was the typical one. So you have the balancer, the application service, and the database. So we start very much. How many people do you need? Okay, we need to support at least 5 million daily active users. That is around 2,000, 25,000 requests per minute. Okay, we start playing with it, and suddenly we saw, yeah, Riak is consuming CPU. There is a bottleneck here. This doesn't scale. What's happening? And we were quite sad. How we can fix that? We start investigation, and what we discover is that, as same as Cassandra, Riak loves CPU a lot. Is, as Cassandra, the best problem that you have, that you need to scale by throwing more CPU power. Okay, we have a problem. What to do now? how we solve this. So we start asking people in the company, people outside the company, what is the common approach to solve these issues. And we say, okay, we have the HA proxy, there is no bottleneck there. The app servers are okay, but then the database is kind of having problems. Okay, let's add memcache. We add memcache, kind of you throw the typical bullet that you say, this is going to solve all your problems, and most of the time it works. The other alternative is that you throw money to the database cluster. That's an alternative, but doing that for all the time maybe is not a good investment. So we say, okay, we put memcache in the middle, we have the memcache, the application is going to the memcache. Hey, is there a key for this user? Yes, good, okay, from memcache. Is not, okay, let's ask the database, Riak. Hey, is there this key for this user? If it is not, we save to Riak, to memcache, hey, there is nothing on the database with this key. This means that we were able to really fast get 99% of hits in memcache and almost 0 gets in Riak, meaning that the database was only doing puts. So let's benchmark again, all the things look good, and the day came. We released the game. Normally when you hear this story, hey, you have to do a backend, it's going to support 5 million daily active users, you need to scale fast and all this stuff. Well, I hear that before, and you go to the day and finally you're waiting for the second user to arrive. On this case, we were lucky because finally, in 1 week, we reached 1.5 million daily active users. So finally, all the times that I hear, hey, you have to scale. Yes. And the funny part was that we were scared about the database, but actually the database didn't have any problem. We were having these numbers, a lot of users, nothing failed. We were kind of weird. What's happening? Why nothing is failing? Okay, let's celebrate. It was fun. Happy, but what's happening in production? How all of this works? Because we know it's working. There is no users complaining, but actually we don't know where are the problems, where are the data, where it's coming from, where it's going. So the first thing is adding monitoring. I don't know for Cassandra, but probably right now you have thousands of options to monitor. We choose Graphite, and we start seeing really impressive numbers. Response times of 1 millisecond from database for the read operations. Response time for write operations up to 4 milliseconds. Oh, wow, that was really good. The next thing is the load. Okay, what is the load of the machine of the React nodes? Well, actually, it's good. It's expected. It's not too much. How memory these nodes are consuming? Well, it's predictable. And with React that you reach the top of the machine, and the latency is going to start decreasing a little bit, but actually not a lot. That was a really surprising effect. The next thing, auth alerting. Obviously we connect Graphite to the first system that we found. On that case was Satan. Satan fetch the metrics from Graphite and say, okay, if the response times from database are getting higher, let's create an alert because probably something is going to explode soon. If you're getting out of memory, okay, probably it's going to explode something soon. This was 1 year ago, and we had a few problems. The first problem that we have was the ring size. On the moment we start, one of the big difference between Riak and Cassandra was, and please Christian correct me if I'm wrong, that on Cassandra you need to multiply by 2 always the number of nodes. I think right now it's fixed, and I think it's the same as Riak. You have a ring where you just can add 1 node and the data is going to be balanced between the nodes. It's really nice. For example, For the people that work with Amazon, maybe you receive one day the letter from Amazon saying, hey, your instances are going to be deprecated and you have to start again with new machines. Well, actually, this is not nice to receive, but you have to do it. Your machine is going to disappear soon. It's on the cloud. There is wind. I don't know why, but your machine disappears. So, what to do on that case? Well, okay, let's create more machines, join to the cluster, and remove the old one. For 5 machines, all the process was done in less than 1 day. On that moment, you say, okay, this is cool. It's kind of, I just replace all the cluster of the database nodes in less than a day. Well, we were surprised. So one of the problems that we have was the Riak ring size. This is this ring, and you have to choose how big is this ring, how many partitions is this ring. We chose a number that was quite high, was 1024, meaning that each node is going to be responsible by 1024 divided by the number of nodes. Meaning that if each process that is responsible of each partition of the ring is consuming one fixed amount of memory, if you have too many partitions, the amount of memory that consumes the machine is too high. Suddenly we were running out of memory, not because being used, because the buffers that were allocated for each of the partitions were too big. And then that brings us to the next problem. Out of memory. How many of you have any out of memory error in production? How many good nights do you have with this kind of things? So in the case of Riak, that was really nice because, okay, you have one machine that is getting out of memory, and then the kernel decides to kill it. It's kind of, okay, good. I cannot survive, so if I cannot survive, I kill you. What's happened to the rest of the cluster? The rest of the cluster is wondering where the hell this machine went. Okay, but still, you have clients asking for you for data. Hey, I need to write this. Okay, this is not there. Okay, I take the responsibility to write this data to disk. Okay, yes, but if you're running out of memory and suddenly you take the responsibility of another machine that is not there, you start consuming more memory. Second machine dies. And then it continues to the rest of them. All of them die. So, solution, increase the memory size of the machine or add more nodes. This is easy to solve by just reducing the ring size. But on that moment, we weren't able to change that number. It's a fixed constant that you have to decide before going live. Other interesting fact is that, okay, one node dies and no one relies. We were having one node down for a week, and it takes us 1 week to realize, hey, there is only 4 nodes working. Where is the other one? Oh, what's happening here? And suddenly you start looking at the numbers, and okay, response times were not affected. The application servers, they were serving at the same speed, the same number of requests, and well, there were no alert because there were no data. So that was another thing that we learned that you need to monitor. So to summary, all these things, you always should take care if you choose the ring size, how many partitions do you have, and you must monitor. The other thing, after 1 year, that I'm pretty sure is really nice, you can trust. We were running this cluster, we changed the machine maybe 10 times already, and we never have any single problem. It's true that our use case is quite simple. We fetch data from the database, and we write data to the database. If you want to carry something special, maybe you can use MapReduce on Riak, but actually we didn't have the need. So with that, that is maybe my short talk. I want to say thanks, and I want to ask you if you want me to go deeper in a lot of the things that we have in production. If you have any questions that I can help, I'm Guillermo, I work at Google, And I'm happy to help you in anything that you have, that you need. Thanks.
Well, thanks. It was very short.
Yeah.
Any questions? What was the biggest problem when you started with Riak?
Trying to understand what distribution, the cap theorem is, all the theory behind that. You know, what is all the things that we learned on the previous talk about Cassandra, most of them apply to Riak. And understanding all this stuff takes a lot of time. You know, and sometimes it takes you to some misunderstanding. What is going to happen if I do this? Okay, first thing that you say, hey, I want consistency. Okay, so let's say that the replica factor is 3, and then say that I want perform the operation with also 3 with this parameter. That means that I'm going to write and wait for the response of 3 nodes. Yeah, you have consistency, but as we say before, suddenly, okay, if there is one node down, you cannot write nothing because it's going to fail. So all the theory behind the distributed system was for me the hardest part.
Okay. What about aggregations? So when I started the first time with NoSQL, I thought, oh, cool, it's super easy to replicate and it's really fast. And when I come to a point that I had to do a simple thing, something like max or min function in SQL, and when I found out, oh, it doesn't work. And when I Googled, and somebody tells me, yeah, you have to do map and reduce, and that was the first wake up for me, what really NoSQL is. How it is with Riak?
It's exactly like that. You have to use map reduce. You can create indexes that you can fetch later on, but for what I hear on the talk about Cassandra, is it shares the basic distribution system as Cassandra, but on API level looks more like, for example, CodesDB, where you have to define your map reduce functions every time you want to carry something. Depending on the data model that you have, could be good, could be bad. On our case was, okay, really simple, straightforward. We need to fetch data and write data. We don't carry data. We have another system that is analytics that defines what are the behavior of the users. So,
yeah, we have a question.
So, if you're just doing key value stuff, why didn't you just use something like Redis, something even more simple?
We have several Redis for different things. Basically, Redis, you can distribute by sharding. That for me is kind of, yeah, it's okay. But if suddenly you receive the Amazon letter saying you have to remove your instance, then you have to manually copy the data. Oh, all the distribution is not built inside Redis. I think they are working onto that. I don't know if they finally release the distributed Redis, but Redis is one process that you start and is running on your machine. I think Redis have master replication, but probably for our use case will be not enough. But yes, we have several games that are using Redis. I really like Redis. On this case, for example, we have some indexes that use Redis, and all the data that is sent to Graphite, some of them for aggregation is sent to Redis. That was a fun problem to have. Redis, if you decide to save to disk, and suddenly you have a 2 GB set, when the system is restarted, it starts listening to the port, and then the application connects to Redis and starts sending data, and Redis doesn't respond because it takes 2 minutes to load the data from disk. So suddenly, all the database was working, but the monitoring system where you send the metrics was blocking the request to continue just because Redis decided to open first the port and then start restoring from disk. But if you can use Redis, use it. It's a pleasure.
I have another question about backup. If you have any backup in place and how you execute the backup of the data to guarantee the consistency in a special way.
Riak doesn't have on the open source version multi-data center support. So we define, we always build the architecture in layers. No? So we define the term of cold data and warm data. The warm data is in Memcache. Well, not so cold data is on Riak, and the frozen data is on S3. So every time a request comes, it first tries to fetch the data from Memcache. The next time it tries, it goes for Riak. And if it is not found on Riak, probably because Riak was restored from in a new data center, it's going to fetch the data from S3. This is a behavior that we define with a flag. Okay, start application in a restore mode. So mostly we delegate the backups to S3. I don't know if that answers your question.
Well, mainly yes, but I know that it's not a simple topic to handle the backup, and it's not a simple topic to have a backup if you want really backup on a distributed system in a special way for consistency. Or you have to do node base or create some specific tool for that.
On our case is okay. We save in Redis a list of the keys that were accessed during the day, and after one day, on peaks, on moments where there is not too much traffic, we start fetching all the keys from Riak and override that in S3.
Yeah, from what I understand, you are not worried to lose 1 or 2 hour traffic or
no.
update.
On our case, is acceptable. In case of data center loss, our plan is to be able to back up and running in less than 5 hours. And if we lose data during the 5 hours, there is going to be a few users that are going to lose the game state. These guys are going to call to the customer service, and maybe we can just say, okay, sorry for that. Sometimes happen. For the moment, never happened. We are happy on that. We just have the technology there to restore it on demand. So the idea is that we fetch from S3 if it is not found in Riak. But on the case of distributed system, my personal opinion is that the distributed system should be already the backup. You should not have an external system. I didn't know too much of Cassandra. All the things that I know from Cassandra, mostly I learned today. And if you have multi-data center replication, I would consider that a backup by itself.
Well, the backup is not the high availability. The backup is to restore a condition, and that doesn't make in a certain point of time. This is the main goal of the backup. With disaster recovery or multiple data centers is more for high availability. That is, from my point of view, a different topic.
Could be. Personally, I will use multi-data center as a solution for backup. It's true that if you go to really high enterprise with a lot of volume, maybe it doesn't make sense. For our use case, will be good enough to have use the multi-data center replication as a way of doing backup of the data.
It doesn't save you from user error, right? You just delete all from game states.
Mm-hmm.
And then you suddenly realize that you were not on the testing database, but on the production database. Then all the replication in the world doesn't help you.
That's true. With the solution of S3, the way we hash the keys to write to S3 allow us. We use the timestamp and we use modulo 6 timestamp. So we are going to have 6 versions of each of the keys. So that is normally good enough for our use case. We are going to have the backups in different steps. But yeah, I see now your point of multi-data center is not the same as backup.
My question is more out of curiosity. You said you have to choose the number of nodes carefully. Do you have any formula, or how do you do this? Like, you came with a number of 2024.
No, the number of nodes is you should not worry about that. The system is going to scale to any kind of to any number of nodes. What you have to decide up front is if you have a ring where all the keys are going to hash into one partition of the key, and that partition is going to decide which node that key is going to be assigned, then the number of partitions that you have on the ring is going to be important. For example, if you have a ring of 3 partitions, then you can never have more than 3 machines, because you can only have keys that end on one server, keys that ends on one server, and keys that ends on that server. For example, for an Avalanche cluster of 32 nodes, having a key of 128 or 512 could be a good starting point for a ring size. On our case, for 5 nodes, having a starting point of 1024 partitions were too much. I don't know if I was able to explain myself, but it's not the number of nodes, it's how many partitions do you have in the ring.
And this you make dependent on the keys, or what is the thinking behind it? So just to follow it to the end.
You normally decide with the number of nodes that you are going to have. If you expect to have 5 nodes, then you should choose one number. You have to plan ahead. What this is the capacity that I'm going to have. For what I hear, Basho guys they know that there is the problem of you not always know the capacity that you're going to need up front. So there is a way to change that ring size. Even I never hear no one using that feature. So you say, okay, there is some formulas on the official Riak page to help you to calculate that number. I don't remember right now. But on average, think that 5 nodes should be 128, 256, maybe 512. I'm talking from memory. We can look later if you want the web page, and I look for it.
Okay, thanks.
Maybe so we don't repeat the same mistakes. How did you guys originally decide? I guess to just kind of maybe get inside your heads a little bit. How did you guys originally decide to choose? What was the thought process that led you to say, all right, we're going to use 1200 and whatever for based on how many nodes you guys start with too, by the way?
Our case was, okay, this is the number of partitions. Maybe we are going to have 10 nodes. We didn't know about the consequences of taking a big number. So on that moment I say, okay, let's put 1024 on this field. I'm used to the Unix that you start a process and then the things go up. Why the hell this database is asking me for data like ring size? What the hell is that? So on that case was lack of experience. The reason because behind that. Then we discovered that affects directly the amount of memory that the process is going to consume. Meaning that, we need to, right now we are forced to have at least 5 nodes running because the amount of memory that this is consuming is too much. We started adjusting the buffers to reduce and the memory, and we were able to more or less fix it. But it's a thing that maybe you don't want to face. Also read the docs. The docs are really helpful for that. I hope you are not like me that say, okay, let's ship this and play with it and see and forget about reading documentation. On this case, documentation is nice.
How do you distribute the request between the single React nodes? Do you have a proxy between the
Yes, we have a small HA proxy in each of the observers that is going to randomly distribute the request to each of the machines. Chef is going to ensure that HA proxy is always pointing to the production React machines. And if one node goes down, HA proxy is just going to ignore that node. So quite classic model.
Thank you.
Right, more questions? So how easy it was to set up the cluster with Riak?
Including understanding all the things that you're doing?
Yes.
That takes more time. Normally, the difficult part is choosing the correct values for all these fields. And then you go to the machine, apt-get install Riak, and then you say start. Once you have that, apt-get install Riak, and that's all the things that you need. If you go for production, maybe before starting Riak, you need to configure and fine-tune some things. But yes, it's quite simple. Then next time you want to join another node, so, okay, you go to another machine, apt-get install Riak, and then there is a command line interface. You can say Riak admin cluster join my friend, and then your node is going to be join the other node. Then all the both nodes say, hey, good. So if before we were having this ring with all these partitions and I was the only one and I was owning all of them, right now I need to share. I don't want to hold all the responsibility of this. So they start hashing and talking between each other and saying, hey, maybe I should take this one. And 50% of the data is going to go to the other node. So it's going to be some time in the transition of the data. For example, right now I think we have 100 gigabytes per node, 5 nodes. That is 500 gigabytes. And every time we want to migrate to a new cluster, it takes 2 hours, actually 4 hours to migrate all the data.
How is the ecosystem around Riak? So Christian told us that there are multiple projects who play really well together with Cassandra. For example, Spark, Hive, and Solar. How it is with Riak?
I think it's different philosophy. All the projects that you mentioned are around the Java community. Riak for me is more, okay, you are building an architecture not from the development point of view, from the architecture point of view, meaning that Riak is a layer and then you create another layer on top of Riak. I think it's different philosophy. Riak offers an HTTP interface, and then you can add your Erlang code if you want to do cool things. Riak is a small pieces of libraries. For example, you can just have the logic. You have a Riak core, that is the logic of this ring, and then you can choose different backends of how to write the data. You have a backend that is using a level DB, the format that I think Google is using for his data center, or partially. Then Facebook have his own fork, and I think you can also use it. Then you have think as Riak as a collection of Erlang libraries, and you can choose each of the parts that you need. For me, Cassandra, coming from the Unix world, feels like, okay, I don't like Java. I just say it. I was trying to say it in a polite way, but yes, it's a matter of taste.
Have another question?
I don't want to monopolize the question time, but I have another question about this. You said that you don't like Java, but Erlang, like Java, is a garbage collected language. So did you have any problems with GC pauses in your production databases?
This is one of the reasons we were having another friend at the company that I think he worked before with Cassandra, and he was putting one to another. So okay, let's do a benchmark with both. What we found is that once you reach the maximum of the machine, the maximum acceptable, the garbage collector on Java was running a lot. Erlang is true that it's a virtual machine, it's a dynamic language, but it's a different virtual machine. For example, Erlang is based on the actor model, and it doesn't have reference. It always passes data from process to process, from thread to thread by copy, meaning that killing a thread is also doing the garbage collector. The garbage collector in Erlang is quite easy. There is no need. You just wait until there is something, but most of the time is you do the garbage collector independently per process. There is no such thing as global garbage collector. There is, but this is not the one that is hitting the performance. So it's different philosophies. Erlang is more, for example, more common use. You can use Java is common use. You can use it for a lot of things. While Erlang, I will say, is a specific for not a specific, but really oriented for distributed systems. Once you get used to programming with this actor model, is a pleasure. Could be in Go, in Erlang, in other languages that use it, and yeah.
So do you see multi-second pauses?
No,
with
no.
Riak?
No. I never saw that. Is that happening, Cassandra? Okay.
I guess kind of along those lines, do you guys have any deep knowledge or guys that do Erlang a lot, or is that actually, has that been an issue for you guys if you have very shallow knowledge of Erlang, dealing with kind of administering it, or dealing with maybe stack traces that will spew out when it blows up? Just can you speak to that, I guess?
Do you know Erlang?
I took a weekend introductory course to it 3 years ago, so
okay.
Probably not.
No, because you say the stack traces, and for me, one of the most difficult parts of Erlang is understanding the stack trace. That was a fun introduction. Yes, at the company we have several people that are experts in Erlang. That also helps in the decision of choosing Riak. That is, we have several people that have really deep knowledge in Erlang and how the virtual machine works, so internals of the virtual machine.
Would you have chosen Riak without those people?
Yes.
Okay, no more questions? Yeah, then I think we make a cut here.